and welcome back to my channel. Today we're going to be learning about how to solve for different parts of right triangles. Any triangle has 6 measurements associated with it, the lengths of the sides and the measurements of the 3 angles created in a triangle. Let's look at this triangle right here and go ahead and label it. So if this side here was labeled as A, the angle here would be measured as a capital letter A. If this length of this side here was known as lowercase b, the angle across from this side would be known as B also. And then if this side here was labeled as C, this angle here would also be labeled as C. So you need to notice how the angle letter is the same as the letter of the opposite side. Let's go ahead and try to solve some problems now. So since the measurement of angle A plus the measurement of angle B equals 90, we know that 90 minus 36 equals 54. So we know that the measurement of angle A equals 36, the measurement of angle B equals 54, and the measurement of angle C is going to equal 90 since we are in a right triangle. Now let's look at our trig functions. We know that the cotangent of 36 equals 50 over A. We know this because cotangent is x over y, or in this case, b over A. And 50 is our b length, so we will put 50 in this place. After moving around, we find an equation where A equals 50 over the cotangent of 36. This simplifies to 50 over 1.376, which equals 36.3. Now all what we have left is to find the length of C. There are 2 different ways of doing this. The first way of doing this is by using the Pythagorean theorem, which states that a squared plus b squared equals c squared. However, another way of solving for the other side is by doing the same way that we did over here. So we know that cosine is equal to x over r. However, in this triangle, that translates to b over c. Since we know that b equals 50, we can write that the cosine of 36 equals 50 over c. We'll multiply both sides by c and then divide by cosine of 36 to get that c equals 50 over the cosine of 36. Once we simplify this fraction, we can see that it approximately equals 61.8. So our length of A is equal to 36.3. Our length of C is equal to 61.8, and we already found the measurements of our other angles. So we have found all the measurements that are unknown in this right triangle. Let's go ahead and solve our next problem. We can see that angle B equals 65.4. Since we know the measurement of this angle and we know that another angle is 90, we can do subtraction to find the measurement of the remaining angle. So 180 minus 65.4 plus our other 90 degrees equals 24.6. So we know that the measurement of angle A equals 24.6. Now we need to find the lengths of the sides. Let's go ahead and look at our trig functions. Which one will be the most useful in helping us find the length of C? Since we only know the length of A, which is 2.35, the best formula is to do sine, which is y over r. So we are going to write that the sine of 24.6 equals 2.35 over C. The reason why we're doing the sine of 24.6 is because we have the measurement of angle A and the length of A. So we put these two together in an equation for trying to find C. Keep in mind that the variables can be changed depending how they are written in the triangle. R, for instance, is another way of saying the hypotenuse. In this case, we can see that C is shown as the hypotenuse in our triangle, so this value will go in place of R in the formula. After isolating C, we can see that the letter C equals 2.35 divided by the sine of 24.6. Enter this value into our calculator and we can see that C equals 5.65. This time, to find our unknown length of the side labeled as B, let's do the Pythagorean theorem. So the square root of 5.65 squared minus 2.35 squared equals 5.13. So the measurements that we found are that the angle of A equals 24.6, B equals 5.13, and the length of C equals 5.65. For this next problem, we are going to solve for a triangle, but the only information that we know are the two sides of a triangle. So when this happens, we need to draw an isosceles triangle. You can see that if we label this side as 31.0 and draw this dashed line in the middle, creating that right triangle, which we are learning about, this side here that is adjacent to angle B would be the length of 15.5. Now, in order to find the measurement of angle B, we need to use trig functions. Since the two values that we know are the same that we need to know for cosine, we are going to use this function. So the cosine of B equals 15.5 over 42.5. This equals to 0.3647. Use the small blue function above the cosine button on your calculator, and you will see that the measurement of angle B is 68.5. Now, let's look at the triangle as a whole. Since this is an isosceles triangle, we know that angle B over here and angle C over here are both going to be 68.5 degrees. We need to take the sum of all the degrees in the triangle, which is 180, and subtract that by 68.5 times 2. This equals 42.8. So we know that the measurement of this angle up here is 42.8 degrees. So we have now found all the measurements needed for this triangle with just knowing the lengths of two sides. Now we are going to solve some word problems which talk about right triangles. The first problem asks, what is the angle of elevation of the sun when a tree 6.25 meters tall casts a shadow which is 10.1 meters long? First, let's draw a picture to visualize what is happening and what angle measure we need to find. So if we look at our triangle here, we are told in the problem that the tree is 6.25 meters tall and casts a shadow that is 10.1 meters long. We need to find the angle of elevation of the sun. The angle of elevation is from the ground up, so we are trying to find this measurement right there. So if we place our sun here, which could also be known as point B, from the sun to the ground, or point C, is 6.25, as we mentioned earlier. Now let's find an appropriate trig function to use based off the information that we have. Remember, we know the lengths of A and B, or better known as x and y. The best trig function to use is tangent, which is y over x. So the tangent of the angle we are trying to find, which is our unknown angle, is going to be 6.25 over 10.1. This equals 0.6188. So now we're going to select tangent to the -1 on our calculator and type in 0.6188. Remember that this will give us the actual value of the measurement of the angle. This comes out to 31.7. Remember to have your calculator set to degrees mode, not radians, otherwise you will get a different answer. So now knowing that the measurement of angle A equals 31.7, we can say that this measurement of this angle right here is 31.7. This answers our question because the angle of elevation of the sun is 31.7 degrees. Here's another problem. It says that the distance from the point directly under a hot air balloon to the point where the balloon is staked to the ground with a rope is 285 feet. The angle of elevation up to the rope to the balloon is 48 degrees. Find the height of the balloon. So if we imagine that our hot air balloon is here, the problem tells us that from a point directly underneath it to another point is 285 feet. In a labeled triangle, this distance would be known as B. The next part of the problem tells us that from that point, which we can call A, to the balloon at point B creates an angle of 48 degrees. Since we know that one angle is 90, we can conclude that the measurement of the last unknown angle is going to be 42 degrees. Now what we need to do is find the correct trig function that includes the angles and lengths that we know and also leads us to the right answer. Since the side we want to find can be also known as y in a graph, and the other side that we know is x, the trig function that we want to use is tangent. So our equation is going to be tangent, right here, of 48 is going to equal the length over here as y that we want to learn over x, which is 285. We isolate y and find that the tangent of 48 times 285 equals 316.5. We can round this up, so our answer is 317. So our length of y, which is the height of the balloon, is about 317 feet. The last word problem we are going to solve today states this. From the top of the 135-foot observation tower, a park ranger sights two forest fires on opposite sides of the tower. If their angles of depression are 42.5 and 32.6 degrees, how far apart are the fires? Let's start off by drawing a picture of what this might look like. In this problem, we are going to be dealing with two right triangles. The first thing we need to draw is a straight line, which will be known as the observation tower. We know that this height is 135 feet. Now, from the top of this tower, we are going to draw two lines going in opposite directions. These lines represent the park ranger's line of sight to the fires which are on the left and right of the observation tower. Once we are done with our drawing, it should look something like this. For this illustration, let's label the points in the big triangle as so. So we know that the angle from point B here at the observation tower to another point is 42.5. And the other point over here is known as 32.6. By looking at the triangles as a whole, we can see that we need to find the distance from point A to point C, which is what the problem asks us to do. So we need to find the lengths of these sides in the smaller triangles. We can use the tan function to find this since we need to find the length of x, and we know the length of y. So our two formulas are going to be the tangent of 42.5 equals 135 divided by x. And for this triangle, the tangent of 32.6 equals 135 divided by x. This comes out to this length being 147 and this length being 211. 147 plus 211 equals 358. So we know that the distance from point A to point C is 358. I hope you learned a lot, and I can't wait to see you in the next video.